Assalamualaikum and very good day to Sir Zikri. Today I will present about Lab 1, Introduction to High Voltage Lab. First of all, this is my group member. My name is Muhammad Syafiq Aziz bin Azizi. The second presenter, Farha Sabrina binti Azhar. The third presenter is Wan Nur Mahaziz bin Wan Nur Syam. First of all, the power cable circuit for the main power supply. The input of the kit 4.0 cabinet is 400 volt for the voltage, 10,000 voltage per amp for the power, and the frequency is 47 to 60 Hz, and it can be variable within the range provided. The output of the kit 4.0 cabinet is 40 volt to 440 volt in single phase. 22.7 amp in current and 50 Hz to 200 Hz is frequency, but 10 Hz to 49 Hz is the rate. Second, the power cable circuit for the frequency inverter. The transformer is the passive electrical device that transfers electrical energy from one electric circuit to another, or multiple circuit. A varying current in any one coil of the transformer produces a varying magnetic flux, the transformer core, which induces a varying electromotive force across any other coils wound around the same core. Electrical energy can be transferred between separate coils without a metallic connection between the two circuits. Faraday's law of induction, discovered in 1831, described the induced voltage effect in any coil due to the changes magnetic flux in circle by the coil. For the question 2, the lamp and alarm circuit. This is the lamp and alarm circuit for the safety purpose of our lab. The lamp and alarm system is connected to testing cage that have been installed together with the frequency converter. For the initial condition or ready condition, the yellow indicator will keep on blinking, then it is ready for installation and testing purpose. When the testing is applied, the green indicator will turn on and yellow indicator will turn off. While testing and fault happen in the circuit, the lamp will change to red indicator and the buzzer will turn on, and it will indicate the person to stop running the circuit and troubleshoot the circuit because it has a fault happen. The test case include a completely enclosed testing area and a dedicated personnel safety interlock system that monitor a single interlock access door and control the application of high voltage. Two components under test to provide personnel protection against high voltage safety hazard inside the chamber. That's all for me. Thank you.
Assalamualaikum and a very good morning. My name is Farha Sabrina binti Azhar. Today I'm going to present about interlock system. For trace interlock system, determine the circuit of the system and how the connection of interlock system from frequency converter to the sensor. For interlock system, it is used to monitor for the door entrance to the high voltage part of the system. It is also used to monitor if the ground rod has been taken out of the high voltage lab. The door can be used as a safety fence that is covered around the high voltage lab. This is the circuit for interlocking system. This is the door and this is the ground rod. A heating plug with 6 pins is used to connect to the interlocking system. There are two normally closed contacts that are used together in this system. An interlock system will work with a dual channel operation. It is used to monitor the discrepant time in between with two contacts. It also has a short detection that is used to prevent the connecting of the circuits together when there is fault case. Next topic is about emergency button. For my question, to identify the circuit of the system and its connection to the control room. The above picture is the circuit for emergency button. For emergency button, it can be used to deliver heating plug with 6 pins. The emergency stop button will work when there are two normally closed contacts that are connected together. Next, the moment the emergency button is activated, all the activity inside the cage is deactivated. This is the example of emergency button that can be found in the high voltage lab. Our instructor used this emergency stop button when there is anything accident happen during our lab. This is the circuit for emergency stop button that can be found inside high voltage lab. This is the emergency button with key. It can also be used to monitor the discrepant time in between with two contacts. It also has a short detection that is used to prevent the connecting of the circuits together when there is fault case. That's all for my part. Next, I will pass to Mahaziz to continue for his next part. Thank you.
My name is Wanur Mahazibunur Sham. So I will talk about the trace grounding system that we have to trace in our laboratory. Simply, there are much of grounding system that we know, but this laboratory I am focusing by tracing in our video from the DR.Zikri video that have been given. So that's let's see with our first. Okay, this is a four picture that we can see in our slide. There is a connecting between the connecting device that connect between primary or secondary to our grounding system. So this picture is come from the transformer. That's when we talk about transformers. So the transformers must be connected to the ground, or otherwise it cannot be any connection of the transformers. So the second picture is a copper braid. Okay, this copper braided wire is a thin copper wire interwoven in the form of braids, which comprise of a common strand constructed from multiple thin wire in what make a braided copper wire. This wire is flat or round shaped, displaying different electrical uses. So in this our laboratory, this copper wire I see that is connected with the ground, and this copper wire is so what we call as expensive. So as we can see, the third picture is a ground switching. This grounding switching is a form of switching that connect the apparatus with the grounding system. And for the last picture is our grounding rod. A grounding rod is usually located very close to your main electrical service panel and is often made of copper or copper coated steel. They approximately have different size, but mostly have a big size, and it must be electrically tied to your main service panel to provide an approved ground connection. If a single ground has a resistance of 25 ohm or less, building code allows it to be used as the only grounding device. If the resistance of a ground rod is greater than 25 ohm, at least one additional ground rod is required. So this you can see that the rod is really important for our grounding system. So next, we can see there are two circuits that I can found, and on my research, this first picture is an isolation transformer grounding layout. In our laboratory, Dr. Zikri have taught us about the ground transformator that must have been grounded to ensure the safety of the instrument. Also, as at the second picture is circuit that we must trace and know by from the switching to the a thing called that a thing called is a chamber that we must connect those of the circuit so that the grounding circuit can be good and can be acceptable. So, as from the laboratory, we managed to understand of this ground system consists of copper braided switch grounding chamber and ground rod to ensure the safety of the system circuit. The grounding system must be in very low potential that required low resistance that based on the regulation must be below than 2 ohm. But referring to IEEE, if the resistance is lower than 5 ohm for the utility testing should be acceptable. As we learned that the laboratory grounding system cannot be connected with other buildings, that's to maintain the resistant grounding and safety issue. Also from the outer terminal will be connected to the chamber that have their own specification copper rod by itself that have been set up in the chamber. The chamber resistance must be lower than 2 ohm of grounding resistance to avoid the unwanted current being floating and can damage the apparatus. If there are any lightning involved in this situation or any other situation, there are special device that must be connected to the grounding system. This is just for an what we call extra knowledge that we get from Dr. Zikri. So that if the resistance not achieve 2 ohm below or higher, the potential will become not proper that can have environment noise from the instrument or surrounding that we can call as background noise. In transformer, the transformer, the circuit on primary and secondary, as I said earlier, must connect to the ground or the circuit will not complete. So that we manage to know how the our grounding system is work. Thank you for listening my presentation. Thank you also listening for our presentation from my friend Shafiq, Farha Sabrina, and myself, Wan Aziz. Thank you and see you again.